Hello everyone. Today we are going to look into LeetCode Problem 55 jump game. So this one is a difficult level of medium, and when coming to the problem statement we are given an integer array, and at each index we have maximum possible steps that we can do, and we need to find if we can reach the end of the array by taking necessary steps. Let's say for 2, 3, double 1, 4. So let's consider like we will start from the zeroth index, and from zeroth index here we have two. That means either I can take one step or two steps. So that means I can move to 3 or I can move to 1 from 2. So same for same for the first index. Here we have 3. That means either I can move to this particular second index or third index or fourth index from second index. So we are at first index, and we can move to either second index or third index or fourth index. And let's try to understand the example one by we work through. So let's say here I have two steps. So let's say I make two steps from here. I'm making maximum steps. So let's say I move from here to here. Here we have one step. That means I can move to only one position. That means I can move to next position only. So from here I move to this position. So from here we have one. That means I can make maximum one step. That means I can move from here to here, which is end of the array. That means we reach to top of the steps. That means we can successfully move to fourth position. Let's see example two. Here we have two false. Let's see how why we are having false. So let's say I'm at third position. I make maximum steps. That means I move to zero. So I end up being in zero. And from here I can't move anywhere. Why? Because we have maximum steps allowed here are zero only. So let's say I have the maximum of three, and I just move two steps instead of three. I can move uh, like less than these steps that are provided in this index, right? So let's say I make two steps. That means I move to this particular step. From here, I can make only one step. Here we have value as 1. That means I can make only one step. That means I reach to 0. So that's it is going on. Like we can take any number from this array, uh, and we can move to 0 only. We end up being in 0 only. We can't move. We can't reach the end. So that's why we are working for this. So this seems like we can solve it in a multiple ways. Let's see if we can solve it using like let's say if we can solve it using any recursively. Okay, so I'm taking example of one only. So I just made a small, you can see there is some binary tree, not a binary tree, it's a kind of tree. What is it representing? So 0 means I'm at first position, the 0th position, and here what is the possibility? So I have 2. Here I have value 2. That means I can make either one step or two steps. So if I make one step, I have possibilities of threes. Three. Why? Because here at one position we have three number, right? So I have three possibilities. From here I can move to two or three or four. So I made these three steps. From these three possibilities, let's say from the second step I have one possibility. That means from here I have one possibility to move fourth step, right? I have one possibility to move fourth step. That is it. That means we can able to move to fourth position. From third index also I have one possibility. From third index, that means here too I have one possibility to move. That is four. And ultimately like here from first index as well we have steps maximum steps 3. That means we can directly move to last index, right? What is the use of this making this tree? So here you can see we have this four, we have three possibilities, and we don't need to find all the possibilities. We just need to find if we can move to four or not. Here it is the length of 5, that means the last index is 4, right? So here you can see we have three possibilities to know 4. That means if I meet any of these conditions, these three force conditions, what I can simply do is I can return true, right? Let's see another example with 3 to 1 0 4. So what is it doing? So let's say I'm at 0th position. I have three possibilities. Either I can move to one index, two index, or three index. Why? Because we have maximum allowed steps of 3. Let's say I move to one step, that is one index. What are the possibilities? Here we have two. Number of maximum allowed steps as 2. That means either I can move to 2 or I can move to 3. After moving to 2, what is the possibility? Let's say I move to 2, what is the possibility? I can only move to 3, there is no possibility. So, okay, so here we are not making our move to 4, so that's why I'm getting back, and I'm looking into the other possibility. Let's say from here, let's say I need the maximum steps 2, that is 3, and it is same for second index also. Let's say I'm in second index, and how many steps I can make? I can only make one step, that means 3, and from 0th index as well, I have only one possibility. The maximum possibility is to move to 3 index. So by from this tree, what we can say is we never made ourselves to 4. That means we can return false. This is one approach we can solve, but actually it is going to take a long time. That means we need to find all the possibilities. Let's say we have 10 numbers in our array. It is going to take a long time. And why it is going to take a long time is we have our constraints. It is clearly given that nems dot length can be less than or equals to 10 to the power 4. So let's assume how many possibilities it's going to take, and how many. It is also dependent on number of steps at each index. So it is going to take a long time. Okay, then then what is our uh, approach to solve this issue? So our approach is to follow greedy algorithm or greedy way. So what is greedy? So here we are particularly following right to left greedy approach to find the uh, find out if we can make two large index or not. So let's see how we can do it. So first I set my goal as last index. Yes, it's fine. To reach last index, first I must reach the just before index of the last. That means here it is 4. That means I need to reach to third index. Then only I can reach to 4, right? Fourth index, right? So that is. So what I'm going to do is I'm going to check if this index, if we can reach this index or not. That means now I will make my goal to this. Okay. Yes, we can. We are having a positive number. We are not having any zero, so we can move ourselves from here to here, right? It is 1. That means we can move to from this index to I can move to this index. That means I can consider my goal as this. Okay. Then I will again check the previous index if I can move to this index or not. I can move my goal to this index or not. Yes, obviously we can make. Why? Because from this index, from this index, I can move myself to this index. That means, let me write it down. From second index, I can move to third index. Why? Because in second index we have maximum allowed steps as 1. By using this, I can move to third index, right? So now we can make our goal to second index. Same again, I'm checking. So if I am able to make my uh, if I'm if ever I'm at first index, can I make myself to second index? Yes, of course we can. We have maximum stress allowed are 3. So now I'm making myself to third index. sorry, first index. So again the same thing. So I'm checking zeroth index, and I'm checking the first index. I can move to first index or not from here. Yes, obviously we have two. That means I'm allowed to make up to two steps from one or two any steps I can make. That means I can make my goal as two. Why I'm making these things is after completing this loop, I will just simply return if my goal is zeroth index or not. If I'm able to make my goal as zeroth index after completing this loop, I can say that I can reach the the actual goal, which is the end of the index, end of the array. Okay, so let's look into the non-working one. That means in which we are having our example, like in which we have considered the example two. Let's try to look into it. So what is our condition? So first I need to check. Here it is the fourth index, it is the third index. So if I can make myself, I am able to make myself from fourth index to third index or not. Obviously, we can't make ourselves because here it is zero. That means we can't make any steps from here. We can just be here only. So my goal will be here only. So I'm not making any changes to this one. So I'm just going back to that my previous step. So that means second. Can I make myself from here to here? No, we can only move to one step. That means we can't reach fourth index. That means I can't move my goal from here to here. Let's check with first index. First index. From first index, can I make myself to goal? No. We can only make ourselves from here to here by using maximum probability. Right. So let's check with the zeroth one. Zeroth index. From zeroth index, obviously I can't make myself from here to here. Why? Because I can only make myself from here to here only. That is right. So that is the only maximum probability steps that we can make. That means our goal remains at the last index only. So it is not meeting our condition. That means here we can say we can make ourselves to last index. Yes, this is our approach. It seems a little bit confusing, but writing code make all our doubts clear. So let's write it up into the code. What I'm going to do, I'm going to take an index. Index is nothing but our goal, or else I can say goal. Okay, goal. Goal is nothing but first initially our goal is to reach nums of length minus one, that is last index. And from here I will just uh, look through. I will just start from goal minus one, and I'm checking if it is greater than or equal to zero and I minus one. That means I'm I'm starting myself from here and moving towards the zeroth index. Okay, and what is our next step? We need to check if nums of I, okay, is not equal to zero. Why? Because if nums of I is equal to zero, we have very good example. If nums of I is equal to zero, we can't move anything, right? We can't move anywhere. That means we can simply ignore this point and we can move to previous index, the next index. Okay, not equal to zero and nums of I. So what is the condition? Nums of I should be greater than or equal to, okay, should be greater than or equals to goal minus I. What is this condition? Let's look into this example. Let's say I'm our goal is at 4, and let's assume that our I is at first index. So what is the value at first index? It is 3, right? Let's write it down. It is 3. 3 should be like whatever the value we have at this index should be greater than or equals to goal minus 1. Goal is nothing but our the index of our goal, that is 4 minus What is index? Current index we are checking. We are checking current index as 1. So which is this is equals to 3. That means this condition is checking if we are having enough steps to make ourselves to the particular goal. Okay. So let's say this condition is successful, and at that position we can make goal to I. That's it. That's a simple thing. And after running through all loop, I can simply check if goal is equals to 0 or not. That's it. Let's give it a try. Yes, those test is successfully accepted, and let's submit it. Yes, it's a best solution. It's beating. It's actually a good solution. So this is my approach to solve the problem. So we follow the greedy algorithm from right to left to find if we can make ourselves from last index to first index. So yes, that is that's it for today. Thank you.